Hello, it's Ms. Santana again. I'm here to go over the algebra review for your final exam, part 2. So we're starting with number 12. Yeah, the other first video is 1 through 11. This one will be 12 through 22. So, starting with number 12, it says, what is the 0 of r of x equals 4 sixths x plus 4? So if you think about 0, which we always told you to remember Xerox, the 0 is the ZE in Xerox. And so if you think about the other words that they use for the word 0, it's x-intercept. And that's basically what we're looking for. So we're looking for wherever this particular graph, which is going to be a linear function, is going to cross the x-axis. So that's going to be what we're looking for. So I'm going to go ahead and use the graph app for this. When in doubt, graph it out. Works for this problem. So x, and then what was that? Plus 4. So there you go. Got a picture of a line. And here's your x-axis. And it looks like it's crossing at negative 1, 2, 3, 4, 5, 6, negative 6. So that's going to be your 0. Now, if you want to make sure and double check, you can use the menu option called 0 in the calculator. You just have to go to menu 6, and you'll see the word 0. And then what you want to do is, here's where you find it. You want to click and drag over it, and there you go. There's your 0. So the answer can be given as negative 6, 0, because that's the coordinate where your 0 is, or just negative 6, because that's the number it is on the x-axis. So let's see what our answer choices are. Okay, they wrote it just as a number, so we are going to go with negative 6, because negative 6, which is right here, is where it crossed through your x-axis, so right there. So I'm going with B. That's going to be my best answer choice. That is my 0. Okay. Alright. Let's move right along. Next question is number 13. Number 13 says, Javier graphs f of x equals x squared plus 3x take away 4 on a coordinate grid. What is the y-intercept of f of x? So f of x is this function here, which I can already tell by the power of 2 there that it is a quadratic function. So we're going to be looking at a graph that looks like a U. I'm going to go ahead and graph it. The y-intercept, though, if you look at that word right there, that's the key word here, is instead of, it's the opposite of a 0, it's where it crosses the y-axis. So we're going to see where this U, and it could be an upside down U, it could be a typical U, but somewhere it's going to cross this y-axis, and that's the number we're looking for. So let me go ahead and graph that function. X squared plus 3x minus 4. So plus 3x, and then minus, which is a subtraction symbol, 4. So notice it's a U. Notice it crosses the x-axis here. These would be your Xerox, which are called 0 roots x-intercept solutions. But notice it does cross the y-axis here. Now to actually find out where it's crossing exactly, I'm going to use a trace. So I'm going to do the 5-1, menu 5-1. And right there happens to be right at negative 4. So these are the coordinates, but if they just want the number that it's on, the y-axis, it's at negative 4. So I'm going to go to my answer choices, and I would choose answer choice F, because that's exactly where this U crosses. And you can draw a picture of it. It's 1, 2, 3, 4. So right here at negative 4, this is where it's crossing. You can kind of draw a picture of what you saw. Oops. Like that, I guess. Probably not perfect, but you can kind of show with a little arrow that's your y-intercept. Okay. Alright, so let's look at question number 14. 14 says function f is graphed below. What is the domain of f? So we're going to look at this picture here, which happens to be f, function f, and we're going to think about Dora, because domain makes me think of Dora. Sorry for the interruption there. So I'm going to think of a T-chart, and I'm going to think of Dora. And Dora is do, and then the raw part would go here. So they want the domain, that means they want the x values. And if you think about it, your x values are these here. So if I look at this picture, I want to see how far to the left it goes, which is right here at 1. And then how far to the right does this go? Well, it stops right here at 4. So, in other words, your domain, your x's, are everything in between these two numbers, including 4. But not including the 1, because notice it's not shaded. So you do want to include the 4, because that is a shaded dot, and then you want to include everything in between. Okay. So I'm going to look at my answer choices. I know it's my x values, so I notice that A has a y in it. Okay, that's gone. Got to eliminate that answer. Not a good answer at all. And I notice D says y also. Okay, that would be for range. Okay, that's out. So now I'm left with two choices. Both of them have a 1 and a 4 in them. So now what I want to look at is these symbols here. Because notice, this here is not shaded. So I know it cannot be this symbol right here. It would have to be this one. I do notice that the 4 is shaded, so again, it cannot be this symbol, it has to be this one. So my best choice is going to go, I'm going with C, okay? Because it's all the x's greater than 1, but less than or equal to 4, okay? Alright, so let's look at number 15 next. Number 15 says, which function is equivalent to f of x equals 3x squared plus 7x minus 6. So here, I mean, we could do the tic-tac-toe again, but I'm going to go ahead and show you a different method, which is simply just using the graph app. We could also use define. We could define x as 3. But I'm going to show you how you can also, since we have one variable in there and they happens to be an x, it's perfect for the graph app. So let's graph this function. 3x squared plus 7x, take away 6. And equivalent means that I need to find an expression that will give me the same picture. Now I'm going to zoom out just a little bit down here at the bottom so I can see the whole picture. There it is. And then I'm going to hit the tab key. There you go. And hit the tab key so I can type in each one of these until I find one that will give me the same picture as this one. So I'm going to try the first one. X minus 6, parentheses, x minus 6. I'm going to put a little times right here in the middle of those parentheses. And put x, oh I'm sorry, x minus 1. Sorry. A little tired here. And then x minus 6. Okay, that's not the same picture. You see how the picture is here and it put the graph over here. So now I'm going to go back to that. I'm going to edit that and I'm going to change it to answer choice B next, which is 3x minus 2 times, I'm going to go ahead and put the times symbol just in case it asks for it, x plus 3. Ah, perfect. So notice that it did change the color. Earlier it was black, it used this color, and now it's purple, or kind of pinkish. So there's your equivalent expression. So the answer choice would be G. So when in doubt, graph it out. All you had to do is graph your question, and then graph the answers. Okay? So that's a pretty easy way to solve those as well. And again, you could have used tic-tac-toe, you could have used define. There's always more than one way to solve a problem, for the most part. Now the next question wants to know, this is question number 16, what is the slope of the line represented by the following equations? So we want slope of this line. Now, one, I could solve for y, which is how we showed you how to do this at the beginning of the last semester. We were doing linear functions. So what we would do is we would solve for the y so that we could make it look like y equals mx plus b. And the number that ended up here would end up being your slope. So we could do that. It's one way to solve it. Let me go ahead and remind you, refresh your memory. You would do minus 10x to both sides. Cancel out the x's. Drop down your 6y. I'm going to drop down my negative 10x. And then after that, I'm going to drop down the plus 12. Now, I still have to divide by 6 to cancel out the 6. So I'm going to divide everything by 6. And I'm left with y equals. Now, I do need to reduce that. So again, you could, if you know how to mentally reduce 10 over 6. If not, you can divide it in the first step. And there's your reduced fraction. So 5/3 x. And 12 divided by 6. Okay, that's easy to do. That's plus 2. So here's my slope. Remember that my slope is a number that ends up here in front of the x, and there it is, 5/3, which happens to be b. Now, let's say that you did that, and then you kind of want to double check. Well, a good way to double check is, let's go ahead and graph. You can graph this using relations. So I'm going to show you how you can graph it. 10x plus 6y equals 12. And then you can use the option menu 833. So if you go to menu, 8 for geometry, 3 for measurements, and there's the word slope. Click on that, and then you just click on the line, and there's your slope. Now, it did give us a decimal, so what we could do is check this fraction that we got an answer of. I'm going to use Scratchpad for that, and take 5 and divide it by 3, Control Enter. Same thing, 1.6. It just happened to round it to 1.67. Okay, so, yep, it matches, negative 1.67. Oh, wait a minute, it says negative. Ah, here we go. See this little negative right there that I overlooked when I dropped it down? It's kind of close to the equal sign, so I didn't see it. So, actually, that's wrong, and the answer choice is D. I am so glad I double-checked it. That's why it's important for you guys to double-check your work. Because, look, I'm a teacher, been teaching 27 years, and even I make mistakes. We're all human. So I did it by hand. I overlooked the negative here, but luckily because I did do it in the calculator, I saw that I got a negative. And so that made me go back and kind of rethink to make sure that that made sense. And if you think about it, it is negative. Look, this line is going down. Okay, so I'm glad I made that mistake so you can see how important it is to double check your work. Alright, so let's look at number 17. It says simplify the expression, and they give you an expression here. So when you want to simplify an expression, either one, you could distribute, collect your like terms. That might be an easy way to do that. So let's try it. 2 times x would be 2x. 2 times a minus 2 would be minus 4. A minus 3 times x would be a minus 3x. And then minus 3 times positive 6. Okay, this is like, you got to treat it like a negative when you're multiplying. So negative 3 times positive 6 is a minus 18. So now what you would do is collect your like terms. Well, 2x and a minus x need to go together. So I'm going to write them actually together. So I'm going to put them together. And that gives me a negative 1x. And then I also have, and I'll do it in a different color, a minus 4 and a minus 18. That need to be together. So minus 4 and a minus 18. And that gives me a minus 22. So I'm looking for an answer that has negative x, because they're probably going to drop the 1 here, negative x minus 22, which happens to be A. Now, I would want you to double check this, so what you could do is also use define. You could define x equals to 3 and plug this in to see what number it gives you and make sure that A gives you the same. You could also graph. I always use the phrase, when in doubt, graph it out. Well, this is a good problem where you could literally graph that expression and find the picture that matches like I did earlier in a different problem. So let's try that. X minus 2, take away 3, parentheses, x plus 6. Let's see what this expression looks like as a graph. Now you might need to zoom out. So I'm going to zoom out, see if I can find this. Here we go. Happens to be a line. So what I'm going to do now is graph my answer, which was negative x minus 22. See if it's the same line. Boom. Green turned to orange. Go Hawks. Alright, so my answer choice. I'm pretty confident this is going to be the right answer. See, I double checked my work. And again, you could have used define as well. Let's go ahead and look at example 18 next. 18 basically is very simple. We had a question like this earlier. It wanted the domain of the function below. So here's your function. They want to know the domain. Again, you want to think of Dora, because Dora will help you remember which one is your domain. Well, it happens to be your x values. So they're basically just asking us for your x values, which is, and they're going to put them in order. So like negative 5 would be first, and then the negative 2, the 0, and the 5. So they actually happen to be in order already. Sometimes they are, sometimes they're not. You got to fix them. So negative 5, negative 2, 0, and 5, I'm going with G. Now, notice that they do have range numbers in there. So those of you who didn't remember Dora, you might have picked maybe these answers because you saw F and you realized, oh, look, those numbers happen to be in the problem. Well, it doesn't mean they're the right answer. That would be for your Y values. So be careful with that. Those are called distractor answers. They want to distract you from the truth, from the actual answer. Alright, so number 19, it says if f of x equals 5x squared plus 5x minus 10, what is the value of f of 5? So we've got a function here, and they want to know what f of 5 is. It says record your answer and fill in the bubbles on your answer document. So this is a griddable. Now, going back to function notation, the f of 5, this is what we need to find out. Like, what would be f of 5? Well, remember, this variable in the parentheses is an x. And that's exactly where this number they have given us is. It's in the parentheses. So that is your x. So if you look at your problem, the function part of your problem, because the f is just a name, the x is the number you want to plug in. So what we can do is basically just plug this in. It'd be 5 times 5 squared plus 5 times 5 minus 10. And again, I would probably substitute and then use the first step. Some of you sometimes make basic mistakes on the math part. You forget about like PEMDAS, which is parentheses, exponents, multiply, divide from left to right, and then add and subtract from left to right. So you might end up answering this incorrectly if you don't follow PEMDAS. So I'm going to go ahead and enter it into the first app. And I'm going to show you a different way where you can use the graph app as well. So I'm getting 140 as my answer. Now, I always like to double check. So another way we could do this problem is, as I always say, when in doubt, graph it out. So what we could do is take this function, we could go to the graph app, graph it, and then do a Control T and look at the table. because what you would be looking for is, again, where the x value is a 5. So we're looking for whatever the y number is when the x is a 5. And so again, we could just graph that. So let's try that. It's 5x squared plus 5x minus 10. Hit enter. Seems to be a quadratic. What I really need, though, is the table. So Control T and just scroll on down to number 5. And there it is. 5 happens to be 140. So my answer is correct. That's exactly what I got earlier. So on your answer document, you would want to put positive 140 and then bubble in the 1, the 4, and the 0. Okay. All right. Let's do number 20 next. Number 20 says, which expression is equivalent to? And they give you this expression here. Now, remember that these are keywords for the menu define, which is menu 1-1. So you definitely want to use the define option here. But you want to make sure you define all of the variables in this problem. So notice we do have an x, we have an a, we have a b, and we have a c. So I'm going to have to define the x first. I can use 3 for that one. I need to define the a. I'll use 5 for that one. B, I'll use 7, and then C, which is 9. So I do have to define all of those variables. Otherwise, this won't work. Now, this is not a good problem to graph, so we would not be able to use the graph app here. But this is going to work just fine. So I'm going to use the first app. I'm going to clear everything out. To the first app, I'm going to pull up the define word, and I'm going to start with the x. Menu 1-1, a equals 5. Menu 1-1, b equals 7. Menu 1-1, c equals 9. 3, 5, 7, 9. Use these numbers for define. Alright, so now that I've defined what every variable is going to be using as the number it substitutes, now I'm going to have to type this in to see what answer I would get. So it's going to do the substitution for me. Let's see what we get here. And I do have to put a little time symbol here. Sometimes you have to add in those multipliers. Alright, here we go. I get an answer of 27. Okay, so now I'm going to look to see which one of these will give me the same answer as 27. So, let's see here. I'm going to go with answer, well, I mean, you can try all of them. But I'm going to go straight to the answer, which happens to be, or it should be, D. Because I know the rules of exponents. So, let me go ahead and try that one. Save us some time here. And boom, there you go. So this gave me 27 as well. My answer choice is D. Okay? Alright, we're almost done here. Hang in there. I know it's been a long year. It's almost over. Alright, so let's look at number 21 next. 21 says, Dr. Connell Freshman Academy selling tickets to a choral performance. So it's like a choir. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior tickets, 2 child tickets. Which system of equations can be used to determine X, the number of senior tickets, and Y, the number of child tickets? Okay, so again, let's go back to the beginning of this. I'm going to go back and look at what I highlighted. So they're selling tickets. And on the first day, that probably was a good thing to highlight here. On the first day, so I'm going to record that. I'm going to put first day. Let's see what they sold. They sold 3 senior tickets, and they do want us to use an X for senior. So 3 times X plus, okay, 3 senior plus 1 child. Okay, they want us to use a Y for the child. So 1 Y. And they said that was a total of $38. Then on the second day, so we got another equation, and it was $52 on the second day, but they sold 3 seniors, so 3X plus 2 child, so 2Y, and they said that was a total of $52. So now I got my 2 equations. This is called a systems. Remember, a system of equations is when you have 2 or more equations. And I ended up with 2. I had 2 totals. Makes sense. So let me look for my answer choices. Let's see. 3x plus 1y. Now they're probably going to drop the 1 like they did here. 3x plus 2y equals, I think the answer choice might be G. Let me look around, make sure there isn't something else that might be also, no. So F is out, H and J. My answer choice that I'm going with is G. Okay. All right. It's not too hard. Just have to look for some keywords. You have to see what the totals are and see what variables you're using to represent certain words. Now the last question here says which expression is equivalent to, and then they give us this expression, and then these are our answer choices. And again, you could tic-tac-toe this problem. You could also graph it. You could use define. So many different ways you could do this. I'm going to go ahead and do the tic-tac-toe method. I really like that method, and I know a lot of you do too. So let's try the good old factoring method. So remember, this is how you set it up, though. Now, in order to get 5x squared, there's really only 2 factors I could use, 5x times 1x. And then to get 2, well, just 1 times 2. If I put the 1 and the 2 here, let's see what we will get. 5x times 1 is 5x. 1x times 2 is 2x. Now the key here, if I got these numbers in the right place, then these 2 here should add up to that number. And they do not. 5x plus 2x is not 11x. So what I could do now is erase these 2 boxes and then switch these 2 around. So I'm going to try the 2 on the top now. I'll put the 2 on the top, put the 1 on the bottom. Let's try it again. 5x times 2 is 10x. 1x times 1 is 1x. Boom, there it is. 10x plus 1x is 11x. So now my answers, my factors would be 5x plus 1. That's one of them. And the other factor would be these 2 right here that are also diagonal from each other. 1x plus 2. Now they might have them switch. I don't know. Let's look at our answer choices. Okay, I know it's not A. 5x plus 1 happens to be here, and then they have the x plus 2 first, so there it is right there. It's okay if they switch them. It's the same thing. So they just happen to switch those. It's not C. I always like to look at all my answer choices, though, just to make sure. It's definitely not D. So, yeah, best choice is B. So, again, I hope you enjoyed this video. I hope that you will study for your final exam. This is a good video to watch maybe the night before or the class before. If your teacher, you know, before you take the test, maybe the teacher before that period will let you watch. So good luck.